A very good day to you, ladies and gentlemen. Welcome and thank you for tuning in. This is Mr. Tenga. I hope I find you well. This is a continuation of our video edition on sequence and series. And in today's session, we're going to be looking at a geometric sequence with terms given in algebraic form. Without any waste of time, let's get straight into it. I want you to consider the following sequence. You are given 4x minus 3. You are given x. You are given 2x minus 5. Notice that all your terms have an unknown. They are given in algebraic form. The first question, 1.1, says, determine the value or the values of x for which these terms form a geometric sequence. Notice it says value or values, and again it's geometric sequence. Now to do that, you say r is equal to t2 over t1, which is the same as t3 over t2. Your second term, which happens to be x, over your first term, which will be 4x minus 3. So you're going to have a new expression as x over 4x minus 3, which is the same as 2x minus 5 over x. Then you don't have a choice here. You've got that equation. You need to solve for your unknowns. You're going to cross multiply. You cross multiply, very important. So through cross multiplication, you're going to get 4x minus 3 multiplied by 2x minus 5. That should be equal to x times x. I am going to repeat the same expression on the next page. So you're having the same expression. When simplified, that expression will give you 8x squared minus 26x plus 15 is equals to x squared. Then I need to standardize that quadratic equation into 7x squared minus 26x plus 15, and that is equal to 0. Then obviously you now need to factorize that quadratic equation. You're going to get your factors as 7x and x in the bracket becomes 7x minus 5 in the first and x minus 3 in the second. Then you need to solve for your x values. You're going to get two x values, the first of which is x is equals to 5 over 7. The second is x is equals to positive 3. It is through these two x values that we need to generate two separate geometric sequences. So I'm going to start off with when x is equals to 5 over 7. So when x is equals to 5 over 7, the second part of the question instructs us to do the following. It says, determine the formula for the nth term for this sequence. So we want to find the formula for the nth term. Notice or remember that we got two x values. So I'm going to start with the first x value when x was equal to 5 over 7. So I'm going to say when x is equals to 5 over 7, we want to generate the sequence there. So to generate the sequence, we're going to say 4x minus 3. We've got x and we've got 2x minus 5 as the original given expressions. But within these terms, in place of the x, in each term we're going to substitute with 5 over 7, leading to 4 times 5 over 7 minus 3 is to 5 over 7, which will give us 2x, 2 times 5 over 7 minus 5. Then obviously we need to simplify that, and we're going to get negative 1 over 7. We'll get 5 over 7, and we'll get negative 25 over 7 as our third term. From these three terms, we need to find the common ratio. So I'm going to say T2 over T1, which is the formula for the common ratio. So it's 5 over 7 over negative 1 over 7. That gives me negative 5. So my common ratio is negative 5. But we move on to the general formula now, which is given in Tn. So it's Tn is equals to ar to the power n minus 1, which is negative 1 over 7 for a and negative 5 for r and n minus 1 as the exponent part. So the formula for this sequence, this specific sequence, when x is 5 over 7, is given by Tn is equals to negative 1 over 7 times negative 5 to the power n minus 1. We move on to when x is equals to 3, which is the second x value. Same thing, we rewrite the same given terms, the three terms, but we repeat the same process of subbing in the x value into those expressions where there is x. We get 4 times 3 minus 3, we get 3, and we get 2 times 3 minus 5. Then simplifying that, we get 9, we get 3, and we get 1 for the values that make up our sequence. So these are the first three terms when x is equal to 3. Then finding our R value, we say 3 over 9 is equal to 1 over 3. Then in the end, we get 1 over 3 as our common ratio. Similarly, after getting that R value, we use Tn now to say Tn is equal to our A is 9, and our common ratio is 1 over 3 to the power n minus 1. Then we can simplify this. We can simplify this because we've got that 3, we've got that 1 over 3. These can be simplified, although you are not obliged to, but we encourage you to do it. So in this case, we're going to have 9 can be written as 3 to the power 2. Then 1/3 can be written as 3 to the power negative 1. I've skipped a stage there and distributed the power outside. Then in the end, we get our Tn value to be 3 to the power 3 minus n as our Tn value. I hope you've understood that and you enjoyed the lesson. I look forward to seeing you in the next edition. Bye-bye.